In this video, we will discuss what we learned in the Advanced Manufacturing module in Labs 1, 2, and 3. Then we will show how we combined all of the methods from the labs to complete a puzzle using the DoBot with a camera and a suction cup attachment. Lastly, we will watch a video demonstration of the DoBot sending and receiving the puzzle pieces.
Procedure 1 of Lab 1 teaches us how to perform point-to-point movement using 3 different motion modes: Move J, Move L, and Jump. Move J involves joint movement, Move L involves rectilinear movement, and Jump involves a trajectory that looks like an open rectangle. The movements differ in ways they move from point A to point B, with Move J moving each joint to its target angle, Move L following a straight line trajectory, and Jump lifting at point A, moving horizontally to a position above point B, and then dropping it down to point B. Procedure 2 demonstrates how to change the end effector of the DoBot Magician from a suction cup to a gripper. Our group then programmed the robot to pick up and move a color block from one location to another. The procedure includes instructions on how to connect and disconnect the suction cup or gripper, program the suction cup or gripper using a flowchart, set the gripper parameters, and even adjust the move point settings if needed. When programming the gripper, it was important to increase the Z position to prevent the gripper from crashing into the table. Lab 2 covers several procedures related to automation and image processing. Our group learned about communication protocols, basic image processing techniques, and how to create a vision-guided automated system. Our group worked on tasks such as controlling a conveyor belt using an infrared switch, picking up and placing blocks using a robot arm, and capturing and processing images. We were also able to measure distances and angles between objects and how to create calibration files. Lastly, Lab 3 involved teaching 2 DoBot robotic arms to communicate with each other through a handshaking procedure. One DoBot sent a color block to a conveyor belt and then sent a signal to the second DoBot. The second DoBot retrieved the color block from the conveyor belt and placed it in a designated spot. The procedure involved 2 teams, with one team working on the DoBot that sends the signal and the other team work on the DoBot that receives the signal. This signal transmission had to be set up between the 2 DoBot robotic arms using an external circuit. The setup enabled the transmission of a signal from the sender DoBot to the receiver DoBot, which can be used to trigger specific actions on the receiver DoBot.
For the sending portion of the final project, we were tasked with identifying letters to be sent to the other team's DoBot. The other team's puzzle spelled out sock and was made up of red letters. Our flow starts after calibration with color extraction so that all letters that aren't red cannot get selected. Next, we create feature templates for each letter using the fast match command. We move the robot to one letter at a time, pick it up with a suction cup, and drop it in a predetermined location that both teams agree on. Once all letters have been placed, we move our robot's arm to a location where it won't be hit by the other team. We conclude the sending portion by sending a signal to the other team's robot to indicate that they can start the receive portion. Next, we'll go over our method for the receiving portion. Once we receive the input signal to start, the camera above the table takes a picture. Using templates we made in the fast match block, we identify the first letter's position as well as the angle from vertical. Then we use the shell module to store this value so we can calculate a new one later. We move the arm to the XY coordinates of the fast match and turn on suction to pick up the letter. Next, we used a second fast match to identify the position and angle of the template cutout for the first letter. After using another shell module to calculate the total angle of rotation, angle 1 minus angle 2, we move the arm to the XY coordinates of the second fast match and turn the suction off. Now the first letter is in its place. We repeat this process for the other 3 letters, and then the puzzle is complete. Let's take a look at a video demonstration of the final product.
In this video, the robot is completing the final task. As explained previously, the robot is using the camera to recognize the shapes of the letters and the colors. Once the correct letters are picked out, the robot then moves them to the other side of the table for the other robot to place into the board. Tape is added over the letters so the suction cup better sticks to the letters. Once the robot is complete, a signal is sent to the other robot for them to start putting the letters into the board. Here's a video of us completing the receive portion of the lab. After the letters are received from the other group and the signal is received from their robot, our robot will pick up the letters and place them into the board. As explained previously, the robot is able to do this as we created shells for the camera to recognize the letters. The robot then recognizes the angle of the letter and uses the calibration file to help locate it and place it in the board.
To recap, in this video we discussed what was learned in each lab in the Advanced Manufacturing module, and we showed how the capabilities were combined, then watched a video demo of the final product. We hope you enjoyed the video. Thank you for watching.